Welcome back to the course. Now we have to go through an exercise, and we have in this exercise we are going to plot Lennard-Jones potentials. So I'll just explain you what the problem statement is, and you have to come up with a solution, and you have to put that into the desired question location that will be, the next what do you call the next card. So in this card, this will be a video, and the next card will be a submission platform where you can submit your code. So please go through that accordingly. Okay, so coming back to the problem statement, you have, let's say, two molecules. In this case, we are considering argon-argon. We are considering three pairs at this moment: argon-argon, krypton-krypton, and argon and krypton. So all of these three pairs will have some Lennard-Jones potential if we plot them with respect to the distance between these two atoms. They will have some varying curves, right? So let's just draw what we are expecting. So let's say draw here. So let's say in the x-axis you have r, which is the distance, and here you have this Lennard-Jones potential, right? So let's say you will have one curve like this, the other one can be a little less shallower, and the third one can be, somewhere in the middle, or can be even more deeper. So these are some of the examples you can expect. I don't know how to clean this now. Ah, here. Okay. So we are expecting three potentials. You have to plot all of them. So what do we have to do? Firstly, as we have learned in the last video, how to calculate the Lennard-Jones potential, you will have two or three problems. First one is argon-argon case, right? So in the argon-argon case is just sigma II, which you can find right here, right? Sigma argon-argon. So that is like two argon molecules, the sigma will be the same. In case of epsilon, it's again the same thing. In case of, like, argon-argon pair, but the interesting part will be the argon-krypton part, where you have to actually use this Lorentz Berthelot rules. So you have to use these rules to find the sigma ij and the epsilon ij, and according to that you have to then plot the Lennard-Jones potential. So it's going to be pretty exciting. On the x-axis you have to plot the distance, varying distances, right? And on the y-axis you have to put the potentials, and lastly is just asking them to compare, So you have all the information that you need. Lastly, I'll also explain, here are the sigma values for argon. This is the sigma value for argon. This is a sigma value for krypton, and same goes for the epsilon values. So you now have everything you need. You don't have to go through any Gromax software or something. I have I've just found this, sigma epsilon value from the force field of OPLS. So you don't have to go through any simulation software, just Python, and plot these curves. So I wish you all the best. See you in the next part. Bye bye.